Good morning, everyone. Don't read the title too much because it's a spoiler. I'm going to just get rid of it. Right, so I'm going to talk about the jawed part of the stem natostome, which were once upon a time, or still, depend on which team you are from, called the placoderms. And in particular, I'm going to talk about the group I highlight. So placoderm are usually divided in fairly stable groups, which are antiars, I can't really see, Pictodon, Arthrodire, and some groups that I put in color, and I'm going to talk about them today. The Renanis, the Petalictida, and the Acanthothoracids. What's going on with placoderm is that these groups are usually just like move around and shuffle depending on like analytical methods or different matrices, because we don't really know much about many of them because we don't have the fossil or enough fossil to have enough data to make the signal very, very, very strong. So, as everyone say, we need more fossil, and sometimes we do. I'm going to bring you here to the Hunsrück slate, which is a very famous fossil Lagerstätten in Germany. Here is where it is now, and where it was back then in the early Devonian. And it's very famous for a lot of invertebrate. They have like pycnogonids, so like sea spiders. They have like trilobite, crinoids, but also contains very interesting stem natostome, particularly these three stars, which are jawless drepanaspids and lunaspids, which is a petalictid, and Gemoindina, which is a renanid. But also contains some mysterious animals. Sorry for the picture, but this is basically what we have now. Some of them are lost forever as well. These were known as the Stensioellid, described by Broily, Moy Thomas, and usually consider, well, usually back then consider a monophyletic group by growth, but can be like divided in two, which are the pseudopetalictids and the Stensioellida. But we really don't know what they are, and in fact, these are probably the last people to talk about them, or at least to present them, and they are usually considered either at the base of the placoderm or nested with some other placoderm like Renanids and Acanthothoracids, as we will see later, or considered non-monophyletic, and with pseudopetalictids a bit more closely related to the other placoderms. And even some authors suggest that they are not placoderm at all, but they might be related to holocephalans, like Philippe Janvier in 1995. So what are these things? Recently, Martin Brazeau and colleagues have CT scanned Paraplesio batis, and they consider it a placoderm or a stem group natostome, without really doing a systematic work though. But the gill skeleton do look like a placoderm. Right, so I'm going to try to answer, and fail some of them, this question, like, is Stensioellida a monophyletic group? Are they placoderm or placoderm? And if so, are they mostly related to some other in-group placoderm or not? That's the hero of my talk, which looks not very nice, look like a spear or something like that. And he was he was like determined by growth as a pseudopetalictida indet. No, sorry, as a renanid, and then it was determined again in the 1994 by Otto as a pseudopetalictida indet. And if you look the outside of this specimen, it kind of looks like pseudopetalictid. He has, can I come here? I can't see from here. Okay. The position of the orbit is look like pseudopetalictida. It have this portion of the occipital joint, it looks something like that, and he has this depression for probably where the nasal capsule were, and this elongated snout, which is a bit different from Stensioella, for example, where the eyes are supposedly to be here, and the skull is a bit more bulky and less elongated. Oops. I put a filter on it, so like, maybe there is something more, and then I CT scan it, and that's what happened. And there is way, way more. So we have almost a complete brain case. We have a very, very good shoulder girdle. We have a synarchial, very interesting. And we have some part of the endocast. You can see some spinal nerves, iomandibular branch. And also like where some of the nerves canal come out. There is a gill arch is hidden there. And it's a very interesting specimen because if you look at the pectoral girdle, you find instead a lot of similarity with Stensioella, which is here, and particularly in these two processes that were considered once a unique feature of Stensioella, processus lateralis, and processus posterioris that are basically, they stay in front and at the back of the fin articulation. And again, this was considered a unique feature of Stensioellida, but now probably is what related these two things together, because it's not present in any other placoderm as far as we can tell. They are here. And basically they make, I think they make the fin very stiff and not really movable. So these things are like rays and they like, I don't know, fly in the water pretty much. The pectoral girdle is similar to pseudopetalictids and is narrow and probably dorsally open. The scapulocoracoid is fused or attached in the midline without medial element. And it lacks long spine and ventral plates like in other placoderm. And this may be character that unite this group, at least Stensioellida and pseudopetalictid and other cranial character. But there are so many things to talk about that I cannot really do all the things now. Big question, is pseudopetalictid a petalictid? It's called pseudopetalictid, so people ask me this. And it kind of looked like petalictid, but not much. And I think the reason why they did is because of the position of the orbit and this supraorbital sensory canal. But actually, the dermal part of the skull looked like more like some acanthothoracic, or like the tesserae acanthothoracic, instead of having these like big plates like petalictids. In particular, petalictids have this very peculiar articular joint where all the articulation is in the middle. Here, the craniospinal process is like vertical, let's say. While, for example, in our specimen, the articulation is completely different. The craniospinal process is a bit more transversal, and the articulation is here. So, sorry, but it's not a petalictid. The occipital joint look more like some other placoderm, like acanthothoracic arabostius, which I think this is strikingly very similar, and Renanid's placoderm, again with the cucullaris fossa is very similar, and this area of the occipital joint is very, very similar. So, Stensioellida is a monophyletic group. Maybe it is, it's not completely sure, but probably. Are they related to something else? So I was very intrigued by how similar these things look like. So this is a Renanid shoulder girdle, and then they have this heart shape morphology outside. And the pectoral girdle is very, very similar. They also have other features similar to Renanid. This is Jaguarina brain case, and there is the antorbital process that is very similar, and this part of the orbit very similar. And in general, the brain case have some similarities, although the subocular shelf here is very well developed. But also have a lot of similarity with some acanthothoracic. This is Arabostius, this is Romondina, and basically the brain case fossae and processes are very, very similar, like parabranchial fossa, hyoidean fossa. What all this mean? Also, they have other features that are shared only between Renanids, acanthothoracids, and Antiarchs. For example, the presence of an ethmoid commissure that is very clear in Stensioella, which is this sensory line that basically go in front of the snout, which in placoderm is only present in these groups. Maybe I went very fast. I don't know what the time is. But to conclude, but there are many, many things to say about this, but I choose only what I thought was important. The new specimen is closely related to Stensioella because of this key feature of having these processes near the fin attachment. Other aspects of the shoulder girdle, morphology, and cranial anatomy are more similar to pseudopetalictis. The new specimen probably represents a new taxon because although it's similar to Stensioella, have a lot of differences as well. Stensioellida, it might be a monophyletic group based on this feature. Pseudopetalictids, and so the rest of the group, are not closely related to Petalictida at all. Stensioellida could represent proximal relatives of Renanid, acanthothoracic, and this means that they can all be related. So instead of being as usually they come out in different position, or I don't know, there's a lot of morphological gap between these forms, but maybe we are seeing something. There are some forms that are more linked and which are more linked morphology based on many characters, sensory line, brain case, and girdle morphology. These reject the Orcphalian affinity for Stensioellida, and I know you're going to ask me about this phylogenetic analysis. This is, I said in preparation, but actually is almost done. But I cannot show because it contains many other enigmatic acanthothoracic or placoderm that look like it. So yeah, these are the people that helped me with this, and thank you.